Welcome to Sundar's lecture. This is lecture number 104, and in this lecture we are going to see representation of ideal transformer using two-port network. See, we are going to apply two-port network in transformers to get the parameters. Maybe we are going for ideal transformers, not the practical transformer. Try to understand. We are going for ideal transformers, right? So, what are the topics we have seen in the previous class? Because that is very important. See, connections of two-port network. We have started with connections of two-port network, series connections, and in series connections, what happens? Z1, these two Z parameters can be added, and if two-port networks are connected in parallel, then Y parameters can be added. That is what we have concluded, right? This is what we have concluded. And in cascaded connections, what we have done? The parameter ABCD parameter of two-port network 1 and two-port network 2 can be multiplied. Finally, it can be multiplied, right? So these are all the concepts we have seen in the previous class, and in today's class we are going to represent the ideal transformer, right? So this is the transformer, you know, right? So this is the primary winding, this is secondary winding, this is input side, and this is the output side, and we are going to connect some impedances here. All those kind of things we have already seen, right? We know the ideal transformer, what ideal transformer means to us, because see, there are so many assumptions were taken. There is no winding resistances in the primary side as well as in the secondary side. There is no leakage reactances, and so many things we have there in the ideal transformer, right? So we are not going very deep into ideal transformer, but how we can represent the ideal transformer using a two-port network. That is what we are going to see. See here, what is this one? We know this one, right? So V2 divided by V1 can be written as what? N2 divided by N1. You know this one, right? So this one we can easily write this one. This is the uh, transformer equivalent ratio, the transformation ratio, or in other hand we can say this is the transformation ratio. So in general, what we do, we can write like N1 by N2, which is equal to A. We can write like this, right? So, what you can write this equation now. So I will write this equation. So V1 by V2, you just inverse this one, can be written as what? A. So in other hand, this equation can be also written as V1 is equal to A into V2. A into V2. Let this be expression number 1, right? And you know the MMF balancing. What is MMF balancing? That one, it is N2 into I2. That is the number of turns. This is maybe I will write it here. This is N2 and this is N1. Both windings. Number of turns. N1 is primary side winding. N2 is number of turns in the secondary side winding. Then if N2 into multiplication of N2 into I2 should be is equal to N1 into I1. This is the MMF balancing. This equation we generally call it as MMF balancing. MMF should be balanced, right? So that is why the frequency in the transformer will be equal. We generally call the transformer as a constant frequency static machine, right? This is a static machine, and frequency in the transformer will be always same in the primary side as well as in the secondary side. That is because of this MMF balancing. And here what you can write this equation as I2 can be written as N1 by N2 into I1. And what you can write, this is A, right? So I2 can be written as this one. This is A, right? That is what we have taken, A into I1. This is equation number 2, right? Now you see here, you can go for ABCD parameter. You go for ABCD parameter, ABC, ABCD parameter. What you can write this expression? This expression can be written as, see, what is ABCD parameter? We generally write this is V1 and then I1, sorry, okay, V1 and then I1, that is input voltage and then input current can be related as A, B, C, D, and then this one, it is output voltage and then output current, output port voltage and then output port current, right? This is the ABCD parameter we always write, right? Now you have the equations, right? V1, what is the V1 equation? That is A into only V2, right? A into only V2. There is no I2 term related to V1. So how you can write this one now? So V1, it is V1 and this is I1, right? Which is equal to, see here, V, that means V2 term is there. What is the coefficient of V2 term? It is A. So you can write A here and there is no I2 term. You can multiply, right? A into V2 plus B into I2. You have only V2 term. There is no I2 term. Put 0 here. And you see here, I can write this as I1 can be written as what? This A can be put down by, sorry, this one can be written as what? 1 by A into I2. You can write like that also, right? So maybe you take this as equation number 2 star. Now you can write I1 in terms of I2 I have written. So there is no V2 here. So this will be 0 and this will be 1 divided by A. This will be 1 divided by A and this is V2 into I2. Now if you simplify this matrix, you will get these two equations. Right now, see here, what is the, you can represent an ideal transformer using a ABCD parameter. A, you can represent it as A. That means, what is A? A, which is nothing but it is N1 by N2, try to understand. And what is D? It is 1 by A. What is D? It is 1 by A. And that, and also you see here, you can also represent these two terms, these two equations. Let me write that one too. What is H parameter? H parameter. See here, I will write that also. See here, H parameter. What is H parameter? See, I will write like this. Maybe I will write it simply. See, this is V1 into I2. V1 I2 should be is equal to H11, H12, H21, H22, H22, right? This will be multiplied by V2 into I1. This is I2, right? So you can write like this, right? So you see here, this one, V1 and I2, in terms of V2 and I1, we have already the equation, we have with us, right? So you can write this one too. See here, I will write here. So this is V1 and this is I2, right? What you can write here? See here, V1 can be written as A into V2. That means this term we have. So H11 will be A and there is no I2 term here. So this will be 0. That's all. And in H21, you see here, H21 is V2 term in terms of I2. I2, we have only I1 in terms of I1, right? Or maybe I made a mistake. Here it is I1, right? So this one, it is I1, right? So now you see here, this one, I1, I2 in terms of A into I1. There is no V2 term, so this will be 0 and H22 will be A. That means A into I1, right? You see here, if you write this equation, if you expand this one, you will get this equation and this equation. See, try to understand that an ideal transformer can be represented by ABCD parameter as well as by H parameter. But you cannot represent the ideal transformer in Z parameter and Y parameter. Why? The Z parameter can be written as what? V1 and V2 in terms of I1 and I2. See, you cannot write V1 in terms of I. You cannot write this V1 in terms of I. That is not possible. No, you cannot do that. So, and also, what is Y parameter? Y parameter is I1 and I2 in terms of V1 and V2. We always try to write like that. And that is also not possible. How you write this I2 in terms of V? No, sorry, I1 and I2 in terms of V1 and V2. It is not possible. So, you can represent an ideal transformer by using these kind of equations, right? And also you can get much more details of an ideal transformer, right? We will go for that. Right. Now you see here, I have taken the same transformer now, the ideal transformer. This is an ideal transformer. Try to understand. I am not going for practical transformer. This is also an ideal transformer. Let we go, we try to apply something, right? What we will do now, we just put an impedance here. That means load impedance. Load impedance. Let this be ZL. And what is ZL? What is ZL? You can write ZL. ZL should be is equal to what? See this one, the current is coming down here. This is V2 from plus to minus, it is traveling. Then obviously it will be V2 by I2. Maybe small letter. This is V2 by I2. This is ZL. Maybe you can write like this, right? So what you can represent here, try to understand me very clearly. You write, this is the representation of the ideal transformer in terms of ABCD parameters. See, I have written this one in ABCD parameters. This is V1, V2, this is V1, I1, and this is V2, I2 in terms, right? So, what you can write here, what is V1? So, V1 can be written as A into V2, right? A into V2. And what is I1? What is I1? I1 can be written as 1 by A into I2. 1 by A into I2, right? This is the equation we know, right? Now, what you do, I try to find what is the input impedance, that means primary side impedance, which means what is the impedance seen from the input side or the primary side. So what is that one? See this one, here we have V1 and here you have I1, and what you do now, it is V1 divided by I1. Try to do that. Try to do that. You just divide these two so that I can write this as input side impedance or primary side impedance, right? And that will be is equal to A into V2 divided by 1 by A into I2. So what I can write finally? That means Z input can be written as this I can be goes to the numerator and it will be A square into V2 divided by I2, right? So finally I can write Z input can be written as A square, and this is nothing but ZL. Try to understand. This is very important. This is very important, right? So what is this one? This secondary side impedance value can be seen from the primary side with the multiplication of A square. With the multiplication of A square. What is the impedance in the primary side? Simply you can write that A square multiplication of this value. What is A? What is A? It is N1 by N2. Number of turns, N1 by N2. You divide these two and put and square, take the square of that particular value and multiply with this ZL, and you will get the impedance in the primary side. See, these kind of things are very important. See, you are just getting all these kind of things with the two-port network. See, simply you write this two-port network and you will straight away get all the values, right? Now, what we will do, we try to connect another ideal transformer in cascaded manner. In cascaded manner. Then what happens? Then how will you see the primary side impedance? How will you relate the primary side impedance with the load impedance? That means the load impedance which is connected in the last transformer secondary side. That also we try to get it right now, right? I will draw the diagram. See here, just I have taken the cascaded ideal transformer now. So what we will do now, we are going to get what is the relation between V1 and I1 in terms of V2 and I2 in a single step. In a single step, you don't need to calculate so many things to find what is the value of V2 and I2. If the transformers are connected in cascaded manner. So what you are going to do, see, this is the first transformer, right? This is the first transformer and this is the second transformer, and this is connected in cascaded manner like this. For example, it is connected like this, right? This is connected in cascaded manner. So what my ultimate aim is to find what is the V1 and V2 relationship. What is the V1 and V2 relationship? See, try to understand. This is this for this transformer. I have taken A1 as the transformation ratio. What is A1 here? Simply A1 can be written as N1 by N2. N1 by N2. You know that one. And for this transformer I have taken A2 to be N3 divided by N4. I am not going to write those kind of things. So simply I have just written this as A1 and this as now A2. Right. Now, if two, just you try to understand, this is one two-port network and this is another two-port network, and you are going to connect those two-port network in cascaded manner, back-to-back connections. And now, you know, for ABCD parameter, we have seen, right? See here, that is what we have seen. We are going to apply here. Simply, we are applying here. So, what we have done here, this two-port network 1 and this two-port network 2 are connected in cascaded manner. And what happens there? The ABCD parameters can be multiplied. The ABCD parameters can be multiplied. Simply, the thing you can write it down here. What is this one? What is the ABCD parameter of this particular transformer? See here, I can write like what is ABCD parameter of this one? It is A1 0 0 1 by A1. That is the ABCD parameter, right? What is this one? See, we have just seen here. See, this is the ABCD parameter. A 0 0 and 1 by A for this one. For particularly this one, I've taken this is A, right? This is A, N1 by N2 as A here. So this one is the ABCD parameter, and see here, that is what I have written here. For this one it is A. And what is the ABCD parameter of this one? Simply you just put this is A2 and then 0 0 1 by A2, 1 by A2. So this is the ABCD parameter of this particular transformer, right? What is A2? A2 is simply N3 by N4, right? Now you can just simply write this is V1 and this is I1. Maybe I will write it in small letter. This is I1. This is I1. See, you try to understand. This ABCD parameter, that is A1 0 0 1 by A1, 1 by A1, right? This one will come, and this ABCD parameter, that is A2 0 0 1 by A2, 1 by A2, and this one should be, this is multiplied, and so I can write this is V2 into I2, V2 into I2. Why? Because this is connected in cascaded manner. Right? Now, how you can write this one right now? How will you write this one? So this is V1 and this is I1, that is in matrix like this. So this one now can be multiplied, right? A1 and A2 plus 0. So this value, it will be A1 and A2. This has been multiplied with this row, and this column has been multiplied. This row and this column has been multiplied, right? And if you multiply this row with this column, this is 0 and this is also 0. So you will get 0 here. And this row with this column, this is 0, this is also 0. So this value will be 0. And this row with this one, this is A 1 by A1 and A2. 1 by A1 and A2. That's all, right? So this one will be this value will be V2 into I2. So finally, what you can write, now you can write this equation as V1 will be is equal to A1 and A2 V2. A1, A2, V2. This is 0. So this is the value of V1. This is the value of what? V1. And what is I1? I1 can be written as, this is 0, this value multiplication of this one. So this is 0. So this value will be 1 divided by A1, A2 into I2. See here. This is very interesting, right? So you don't need to calculate anything. It is not at all necessary. See, if you uh, solved this problem in an ideal transformer. So many students would have solved these problems in ideal transformers. If you study electrical machines, that means transformers, you would have solved this problem. That means ideal transformers connected in cascaded manner, and you try to find what is the value of A1, A2. A1, A2 is just very simple, but you will find this values, this value, that value, and so many things you would have found. But what is the thing here? It is simply can be written like this. It is simply can be written like this. Also, if there is if there is any impedances connected here, that means the load impedances has been connected. That if impedance is connected here, then only the current I2 can flow. Then only this current I2 is valid, right? So what is that one now? So if you want to find what is the input impedance, what is the input impedance? It is V1 by I1. Also can be written as what? A1 A2 into V2 divided by 1 by A1 A2 into I2. And you can simply write this is Z input can be written as A1 into A2 the whole square, A1 and A2 the whole square, right, or A1 square into A2 square, and this value will be Z. It may be if you connect an impedance here, that will be ZL. So you can also find this relationship too straight away. Straight away also you can find this. See what we have done here. See, we have considered this transformer as a ABCD parameter, as an ABCD parameter. And if it is connected in cascaded manner, you can simply multiply. You can easily write this one, right? This is A1 0, 0 and A1, 1 by A1, and this value will be A2 0, 0, 1 by A2. And you multiply these two, and you can relate that with V1 and V1 I1 with these two ABCD parameters multiplied with V2 and I2. Simply, just we have got all the answers, what is V1, what is I1, and what is Z input also. We have got everything, right? So it is very simple now. You try to put the values here. You can put the values. For example, if they have given you what is V1 and they have given you what is N1 and N2, and if they have given you what is the value of V2 and they have given you N3 and N4, you can easily find what is the value of V1 and V2. If they are asking you to find what is V2, if they have not given you what is V2, simply what you do, what is V2? V1 divided by A1 into A1 A2. That's all. You don't need to go very deep into this one. So this is the application of the two-port network, particularly ABCD parameter, because we have not seen problems for ABCD parameters. That is why I have taken this one. See, we have not solved any problems related to series and parallel connections and cascaded connections, and we will see some problems in the next class. We will see some problems in the next class. What is those problems? See, series connections. Then what happens? If we are connected to parallel networks, then parallel two-port network. Then what happens? And we will take this one. This cascaded transformers. We will see that in the next class, right? So we will take a numerical problem in the next class and we try to solve those kind of things, right? So what are all the topics we have seen in this particular class? See, we have started with the representation of ideal transformer using two-port network. See, we have taken an ideal transformer and we have just written what is the transformation ratio N1 by N2 and MMF balancing equation, and we try to write, we have written what is V1 and I2, and we have just tried to write these parameter with respect to ABCD parameters, right? We have just written here, and also H parameters can be also written for this particular ideal transformer. So an ideal transformer can be represented in ABCD parameter as well as the H parameter, and we have taken the ideal transformer, how you can represent the primary or input side impedance with respect to the load impedance, that is what we have seen here. And also we have taken the cascaded ideal transformer. So what we have done, we have just connected two ideal transformers in cascaded manner, and we try to apply the concept of cascaded two-port network connections here, multiplication of two ABCD parameters. And we have just written the relationship between V1 and I1 in terms of V2 and I2 straight away in a single step. That is what we have seen in the previous class, right? So we will take numerical problems in the next class. Thank you.